An invisible threat lurks in our midst. We share our planet with a hidden danger. It is a threat we can't see with the naked eye, yet it is all around us. This threat is microplastics. These tiny plastic particles have infiltrated our environment. Microplastics are everywhere. They are in our oceans, rivers, and soil. We even find them in the air we breathe and the food we eat. These particles are less than 5 millimeters in size. Some are so small they are microscopic. These particles are not a natural part of our world. They are a product of human activity. Every plastic item we use has the potential to break down into microplastics. The pervasiveness of microplastics is alarming. These particles are a global concern. We must understand this threat and take action to protect our planet and ourselves. Microplastics come from a variety of sources. Some are manufactured to be small. These primary microplastics are found in cosmetics and industrial abrasives. They enter the environment through wastewater. However, the majority of microplastics originate from larger plastic items. These secondary microplastics form as plastic breaks down. Sunlight, wind, and waves degrade plastic. This process creates smaller and smaller fragments. Consider a plastic bottle discarded carelessly. It might end up in a landfill, a river, or the ocean. Over time, this bottle will fragment into countless microplastics. These particles can persist in the environment for hundreds of years. Our clothes are another significant source of microplastics. Synthetic fabrics like polyester and nylon release fibers during washing. These fibers are too small to be caught by filters. They flow into waterways and eventually reach the ocean. The journey of microplastics often begins far from the ocean. Rainwater washes these particles from city streets into storm drains. Rivers carry them downstream, gathering more plastic debris along the way. Eventually, these rivers empty into the ocean. The ocean becomes the final destination for much of our plastic waste. This constant influx of plastic has created vast garbage patches in our oceans. Once in the ocean, microplastics become part of a complex and interconnected ecosystem. Marine animals mistake these particles for food. Filter feeders like mussels and oysters ingest microplastics as they strain seawater. These tiny plastic particles then move up the food chain. Small fish consume contaminated plankton. Larger predators eat these fish, accumulating higher concentrations of microplastics in their bodies. The consequences of microplastic pollution are devastating for marine life. Seabirds, turtles, and marine mammals often ingest plastic, mistaking it for food. This can lead to starvation as their stomachs feel full of indigestible material. Microplastics can also cause physical harm to marine organisms. Sharp plastic fragments can injure internal organs. Tiny particles can lodge in gills, interfering with respiration. Beyond physical damage, microplastics pose a chemical threat. These particles can absorb persistent organic pollutants from the surrounding seawater. POPs are toxic chemicals that can accumulate in the food chain. When marine animals ingest microplastics, they also ingest the harmful chemicals they carry. This can disrupt hormone function, impair reproduction, and even cause death. Section 5. Invisible intruders: how microplastics infiltrate our food chain. The pervasiveness of microplastics in the ocean has alarming implications for human health. As microplastics accumulate in marine organisms, they also enter our food supply. We consume microplastics when we eat seafood. Fish, shellfish, and even sea salt can contain these tiny plastic particles. Studies have found microplastics in a wide range of marine species consumed by humans. The exact amount of microplastics we consume varies depending on our diet. However, it is clear that these particles are entering our bodies through the food we eat. The question is, what happens to microplastics once they are inside us? Research on the fate and effects of microplastics in the human body is still ongoing. Scientists are working to understand how these particles are absorbed, distributed, and eliminated from our systems. Section 6. The body burden, microplastics, and human health concerns. The presence of microplastics in our bodies raises concerns about potential health risks. While more research is needed, scientists are investigating several areas of concern. One concern is the potential for microplastics to leach harmful chemicals. As mentioned earlier, microplastics can absorb persistent organic pollutants, or POPs, from the environment. These POPs include chemicals like PCBs and pesticides, which are known to be endocrine disruptors. Endocrine disruptors can interfere with hormone function. potentially leading to developmental problems, reproductive issues, and even cancer. Another concern is that microplastics may trigger inflammation in the body. When microplastics enter the bloodstream, they can trigger an immune response. This inflammatory response, if chronic, can contribute to various health problems. Finally, there is concern that microplastics may act as vectors for harmful bacteria and pathogens. These tiny plastic particles can provide a surface for bacteria to attach and grow. Section 7. Unraveling the risks, emerging research on microplastics and disease. The study of microplastics and their impact on human health is still in its early stages. However, emerging research suggests a potential link between microplastic exposure and various health conditions. Some studies have found associations between microplastic exposure and inflammation in the gut. Chronic inflammation in the digestive system can contribute to irritable bowel disease, Crohn's disease, and even colon cancer. Other studies are investigating potential links between microplastics and metabolic disorders like obesity and diabetes. Some researchers hypothesize that microplastics may interfere with metabolism and contribute to insulin resistance. While these studies provide valuable insights, it is important to note that more research is needed to establish definitive causal links between microplastic exposure and specific diseases. Long-term studies are necessary to understand the cumulative effects of microplastic exposure over time. It is also crucial to determine safe levels of exposure and identify vulnerable populations. Section 8. Turning the tide: global initiatives and innovations to combat microplastic pollution. Addressing the global challenge of microplastic pollution requires a multifaceted approach involving government regulations, industry innovations, and individual actions. Governments around the world are beginning to recognize the threat of microplastics and implement policies to reduce their use and release into the environment. Bans on microbeads in cosmetics and restrictions on single-use plastics are positive steps in the right direction. Innovation and technological advancements also play a crucial role in tackling microplastic pollution. Researchers are developing new materials that are biodegradable or compostable, offering alternatives to traditional plastics. Waste management systems are also being improved to prevent plastic waste from entering the environment. Advanced filtration systems are being implemented in wastewater treatment plants to capture microplastics before they reach rivers and oceans. Section 9. Empowering change: individual actions to reduce microplastic footprint. While systemic changes are essential, individual actions can also make a significant difference in reducing our collective microplastic footprint. By making conscious choices in our daily lives, we can contribute to a cleaner and healthier planet. One of the most effective ways to reduce microplastic pollution is to reduce our consumption of single-use plastics. This includes items like plastic bottles, bags, straws, and food packaging. Opting for reusable alternatives significantly reduces plastic waste. Another important step is to choose natural fibers over synthetic ones whenever possible. Clothing made from cotton, linen, wool, or silk releases significantly fewer microplastics during washing compared to synthetic materials like polyester and nylon. Supporting companies and organizations committed to sustainability and responsible plastic use is also crucial. Choosing products with minimal packaging and opting for brands that prioritize recycled materials can drive positive change. Section 10. A future free from microplastics, a shared responsibility. The issue of microplastic pollution highlights the interconnectedness of our planet and the profound impact of human activities on the environment and our health. It is a global challenge that demands a collective response. By raising awareness about the invisible threat of microplastics, promoting responsible consumption patterns, and supporting innovative solutions, we can work towards a future free from plastic pollution. It is a shared responsibility to protect our oceans, our planet, and ultimately our health. By making conscious choices and advocating for change, we can create a world where future generations can thrive in a clean and healthy environment, free from the threat of microplastics.